this video, we're going to import a JSON file, read it, and clean the data using Python. Now, what is JSON? JSON is a lightweight data format for storing and transporting data between systems. It's often used when data is sent from a server to a web page. JSON stands for JavaScript Object Notation. It is self-describing and easy to understand. This is an example of a JSON. There is an employees object, and that object has an array of 3 employee records, first name and last name. If you look at the syntax rules, data is in name value pairs, so employees is the name and this is the value. Data is separated by commas. Curly braces hold the objects, so here the employees object is held in curly brackets, and square brackets hold the arrays. So coming to our JSON file, this file called newsample.json contains a JSON array and which is holding different objects. These are all the different objects. It looks like a Python dictionary where we have the name value pairs and we have a lot of these objects inside this JSON array. Let's jump into the analysis. I'm launching a new Jupyter notebook. Rename the file. First, I'm importing the necessary libraries. Now this pprint library is also called pprint. This is used to make JSON human readable. Now counter is used to count the occurrences in a list, tuple, string or new iterable. Now I'm loading the JSON and checking the data. Now to load the JSON, we use this command. Now this .load method returns a list of dictionaries. Now I'm checking the length of the list. We have 60,000 news articles inside that JSON file. Now I'm slicing the first 2 elements of the list and printing it to check what the data is. We could see it is not readable. That's why we downloaded pprint. So let's use pprint to read the articles. Now we could see it's much more readable if we use pprint. Now this dictionary has some keys and values. This dictionary also has some keys and values. But what if some of the dictionaries don't have the same number of keys and values? Now I want to check the length of all items in the dictionary. For that we use counter. We got this output. What this output means is there are 57,202 dictionaries which have 9 keys. So these are the keys: date, domain, panel position, query. So these are 9 in number. So these type of dictionaries are 57,202 in the file, and we have 2,382 dictionaries which have only 2 keys and values, and we have 416 dictionaries which have 10 keys and values. Now let's check the dictionaries which have only 2 keys. For that I'm using a generator expression. If you look carefully, I'm not using square brackets for this comprehension. I'm using parenthesis item for item in news articles if length of item is equal to 2. This is called a generator expression. This is more memory efficient than list comprehensions. It iterates one item at a time. Now to print the first dictionary with 2 keys, we use the next method. If we check the type of the dictionary with 2 keys, it is a generator type. Now let's check the dictionary with more than 9 keys. I'm directly using the next in the print itself, so it will print the first item in the list of dictionaries with more than 9 keys. So this is the first item. This particular key value pair category is the additional item or the 10th item in the dictionary. That's why it has more than 9 keys. Now I'm selecting the dictionaries with more than 2 keys as the final data. So the final data, I'm using a list comprehension here. Item for item in use articles if length of item is greater than 2. All the dictionaries with more than 2 keys will be in the list of the final data. Let's check the first 3 items. So these are the first 3 items in the final data. Let's check the length of the final data. We have 57618. Remember, we used to have 60,000 articles. Out of those, we removed all the articles which have only 2 keys, and we selected this plus this, which is amounting to 57618 articles. Now we have a key called source in the data. I want to look at all the sources in the final data. So sources is item.get source for item in final data. Now I'm slicing the first 5 elements in the sources list. In the sources list, these are the first 5 items. Now I want to print the 10 most common sources. For that I would use a counter and most common method. These are the top 10 sources or the most common sources. Fox News source has 3530 dictionaries in the final data. CNN.com has 2750 dictionaries in the final data, and so on. If you look at The Hill, these 2 items are actually the same. It's just a difference in the space character, and the counter is taking it as a different data point. If we could fix this error, we could combine these 2 items. I'm writing a for loop here. I'm updating the dictionary with this value for k comma v, key comma value in dictionary.items. If k or the key is source and value is The Hill without space. Now let's run the sources once again. We'll get the source from the final data. Now let's again print the top 10 sources. Now we could see The Hill, both of these are combined and added, and The Hill climbed to the top of the list. Now let's create a data frame from the final data. The command is df is pd.dataframe of final data. Now df, let's check the data types. These are the different data types, objects and int. Let's check the first 3 items in the data frame. So we got the first 3 items. Let's rename the date column. The date column should be replaced with storydate. In place is true. It is replaced. Let's change the data type of the storydate. We'll change it to date time. So df dot storydate is pd to date time. So we could see the storydate data type has changed. Check the shape of the data frame. df.shape. Check the value counts of the sources column in the data frame. df.source value counts. Sort is true. Let's check the top 10. This data should match with this data which you have printed before changing it to a data frame. So that's how we could read a JSON array, clean the data, and import it into a data frame. That's all for this video. Thank you for watching.